Here we have this 1958 Zenith 500D transistor radio, and I've put the batteries in and it doesn't work. So we're going to have to figure out what's wrong with it. This 500D means, the D means distance, and it's a souped up version of the regular Royal 500 series. It has an extra RF stage, which increases the sensitivity quite a bit, I understand. So this will be an interesting radio to get working and see how sensitive it is. It takes 4 AA cells, and I've put them in and I don't get any sound. Here's a schematic of the radio. You've got the extra RF section, got a separate oscillator, a mixer, first and second IF, driver, and a push-pull output stage. It's got there's an electrolytic, 50 microfarads. Here's another one, 50. And right here is a 3 microfarad. So if that 3 microfarad that comes out of the volume control has gone open, there'll be no signal going to the driver transistor and the radio will be silent. So the first thing I'm going to do is I'm going to check for signal on the wiper of this volume control. I'm going to do that with the signal tracer. Here's the signal tracer set up for tracing audio signals, and you just take the input part there. There's a probe that says audio input, and you attach one part to ground, and the other red input goes to whatever place you want to check for audio signal. Here I've got the signal tracer attached to ground, and the middle wiper of the volume control, and I'm not getting anything. Now I've checked, I've taken the RF probe and I've gone just casually through the whole circuit, and also here on this side of the diode, and I've got absolutely nothing. So it seems like the RF section is dead. Maybe the oscillator's dead, or the mixer, some bad transistors. So I'm going to have to use a scope now and see if the oscillator's working. Then we'll check the RF section, mixer, and the 2 IF transistors. I took the radio out of the plastic nylon chassis, and I took the speaker out and disconnected it so that I wouldn't damage it. And this is a most unusual speaker. I've never seen a speaker like that before. It sticks out instead of sticking in. Other than that, everything else seems to be conventional, except for that cone that's sticking out. Very weird. Now, the 3 electrolytic capacitors, this one, and that one, they're all very accessible, and I've measured them, and they are all way out of tolerance. So I'm going to have to replace those before I start to troubleshoot the radio. One good thing about this radio is all the transistors are in sockets, so they can just be pulled out and tested on a transistor tester. I've started replacing the electrolytic capacitors. There's the first one I've replaced. Used a bit of electrical tape to insulate it. That's the original tape. I'm trying to keep it as original as possible. So I'm going to use that original tape that's holding down everything. I'm just going to put a bit of glue on it. And that will hold it in place. And now up here, I've taken out, here's two others. There's the 3 microfarad and 30 microfarad there, and those will both have to be replaced. But I'm going to do it in such a way as it's they fit back in the same positions that they were, so that everything goes back easily into the original spaces. There's the capacitor I just cut out of, it was over here underneath the tape, and there's the end of the wire. That's in the same position I took it out, to remind me that positive is on the left, and I'm going to have to attach the positive lead of the capacitor to the left hand side. There I've replaced the 3 capacitors, the 2 in that section, and there are the old capacitors. See, you can see them right under, the new ones right underneath the tape there. Very tight fit. So now I'm going to go on and look at, I'm going to reconnect the speaker and see if that makes any difference, which I doubt, but I'm going to take a try anyway. There I've hooked the loudspeaker up. I know the speaker's good because I put a battery across it and it clicks. So here I'm getting nothing. And I just put it on the scope. There's nothing, no signal on the scope. That's across the loudspeaker. There should be something there if it was working, so, but absolutely nothing when I tune through the band. So I'll have to start troubleshooting transistors. This Antec handheld oscilloscope is a multifunction instrument. It has a scope and a digital multimeter. So I've taken the signal generator portion and I've hooked it up to the speaker just to verify that the speaker is good. Even though it clicked, I just want to hear if it works well with a tone, if it sounds good. Okay, that's fine. Now what I'm going to do is I'm going to go in and feed a signal into right here at the wiper of the volume control. I'm putting a 1 volt peak-to-peak signal into the volume control of the right at the wiper, and I'm not getting anything. So first I'm going to look at these 2 output transistors and the driver transistor and see if they're faulty or not getting power or whatever. I'm feeding a signal into this point, going into the output transistor, and also this point, 1000 hertz cycle, and at 1 volt peak to peak. But it doesn't matter if the power's on or off, I'm still getting that noise out of the speaker. Here's the power off, and there's the power on. Makes absolutely no difference. So I'm gonna have to check the power going into there. Now I've put one of the push-pull transistors in the transistor tester, and it comes out working fine. Here's the second one, and it's perfect also. Putting the transistors back into their sockets is difficult. You need to really shine a strong light right down, so you can see the socket. And the bottom of the transistor has two pins that are close together, and one that is offset. So getting those oriented in the right place is very difficult. Here we're testing the driver transistor, and it's okay too. Here's the first IF transistor, and it's good too. Here we have the other IF transistor, and it's good too. Here we're testing the oscillator transistor, and it seems to be okay too. And finally, the last conventional transistor that I am checking is the mixer, and that seems to be okay too. The RF transistor is a bit different. I can't test it in this tester. I'll have to use another type of tester. Here is a transistor tester that I made many years ago, and it basically will tell you, you hook it up, you hook the leads up to a transistor, and it'll tell you if it's NPN or PNP, if it's a good transistor. And if both of them light up at the same time, you have a bad transistor. So this transistor is, one here is kind of weird. It's got 4 leads. And normally in newer technology, a 4-lead transistor in let's say, just zoom in there, have a get closer look at it. A 4-lead transistor, if this was from the 70s or 80s, this radio, I would say that this was a MOSFET, which was found in the inputs of a lot of solid state shortwave radios. But being from 1958, I would assume this is a special type of RF transistor that has an input shield. And I've never seen that before, but I guess Zenith had these made specially. It doesn't even show it on the schematic that it's a special transistor. So anyway, I'll assume that it's just a normal PNP or F transistor with an outside shield. So I'll test it and see. It seems to be mostly okay. There's a bit of leakage. That's why the NPN is lighting. But I don't think it's enough to make it not work. So I'll just assume this transistor is okay. If not, I can always substitute another one in. There's something really weird about this radio here, what I'm working on. It's the current consumption. Now, I've got this very similar Zenith Royal, first generation from about 1955-56, which works perfectly. I put the batteries in its battery cabinet, and look at the power, or the current consumption. It's 7 milliamps, and that's with the volume turned right down. Now look at how much it's different when I do the same thing to the radio I'm working on. So I put the batteries back in the battery case, and I'm taking the amount of current that is going to the radio when it's on at low volume, and I'm getting 0.307, 305 milliamps. The other one was over 6, and this is only 0.3. That is weird. So I'm going to, all the transistors are good. None are shorted. If any were shorted, it would be taking higher current than normal. So I'm going to have to ponder that one and think what could be causing that. Looking at the schematic, I'm suspecting this resistor, 100 ohm resistor, which feeds all this, feeds all the transistors here. and also it feeds the driver transistor, and anyway, it feeds most of the transistors, so I suspect that might have gone high. If that had gone high, that could explain why I'm only getting 0.3 milliamps going through there. So I'm going to take out this resistor, and I suspect here's the lead. Where are we here? Here's the lead. This red lead goes down into there, and I think one of these two resistors is the 100 ohm zone. Let's measure both of them. It took about 10 minutes using a solder sucker and a low wattage soldering iron to get that solder off, so I can take that part of that resistor out to test it. That solder just didn't want to come out, but now it's clean, and the three leads there are the wire that comes in from the power, the 100 ohm resistor, and one other which I'm not too sure. Here, the point that I've taken all the solder lines out, it was this 100 ohm resistor and a 4700 ohm resistor. So I'm going to check both this 100 ohm and this 4700 ohm resistor. Here you can see I've got them out, and I'll check them both. The 100 ohm resistor measures 97, so that's well within the range of what I want to see. Now I'll check the 4700 ohm. So here I'm measuring the 4700 ohm capacitor, and it's a full scale 20,000. So this is, I'm measuring kilo ohms, so this is 4.995 kilo ohms. That's within spec. So neither of those resistors is the problem. I'm measuring the resistance to ground here, and I'm getting about 573 ohms. Here, 573 ohms. And that's not anything out of the ordinary. I'll have to look elsewhere for the problem. There are the components stuffed back in their holes, and now I'm going to solder them. There I've resoldered all the connections, and I'm going to look into some other areas which might be causing the problem. So I disconnected the batteries, and I fed in 6 volts to the radio from a power supply, and now I'm getting, it's drawing 9.5 milliamps, and at almost 6 volts. The reason why I never checked the power supply before the batteries is because all the connections look really good. That's why I suspect it's something in the circuitry. One problem, though, is that now it's drawing the right amount of current, but I'm getting nothing out of the radio. Got nothing out of the speaker. So I'm going to have to start going through with this with the signal tracer again, and then I'm going to have to solve the battery supply problem, which I would assume is just a bad connection. So we'll leave that for the end. I'm going to go back to the signal tracer, see if I can hear anything. I took the signal generator and checked the audio section. I didn't get anything. I used the audio trace or this RF tracer, and I didn't hear anything either. Now I'm taking a scope to this area, which is over here, and I'm not getting anything there either. I'm looking for specifically a signal from this oscillator, and the signal is sent to the mixer, and I'm not getting any signal there either. So I'm going to have to really go into and check for bad solder joints, and that's what I suspect. It's probably bad solder joints. So that is a very common thing, so we'll just go through until I find it. I was doing some continuity checks, and I was measuring the resistance from this base of this transistor to this transistor, and that would give me the resistance through the transformer, and it's open. So I ended up looking at the circuit board there, and I could see a visible crack across it, which has caused this to be broken, this, and possibly down here. So I'll have to resolder all those connections and see if that makes any major difference in the performance of the radio. Just a side note, this is probably caused just by constant use, constant turning of the volume control and flexing. And it's just, I don't think this radio was dropped. Doesn't seem to have any damage on the output. This just seems like constant flexing caused this over the years. Here I've actually put along here a piece of wire, which will give it strength and will allow it to flex in the future. Down here I'll have to put the wire too. So 3 more solder bridges with wire. If I just put solder in there, it would probably come apart eventually again. So this will be a permanent fix. So I bridged each one of those 4 traces with wire and soldered them. And now I'll connect the radio to the speaker and see if we hear anything.
We saw from Daniel 9:24.
The radio is working now and seems to be pretty sensitive.
Incredible player I've ever seen. CBC. Hands free call, please, pound.
Hear a lot of background noise.
Election year, we wouldn't do anything like that. Treatment sign.
It's early in the morning and yet it's still picking up stations hundreds of miles away. The volume control is a bit noisy, so I'll work some cleaner in there. And also, I've also hooked it up to the batteries, and now it seems to work okay, so I'm glad there's no battery problem. The tone is reasonable, but it's easier to judge a transistor radio once it's back inside its case. I'm going to do some cleaning up of the outside case before I put it together, and I'm going to dust that speaker, maybe take a light brush to it. But other than that, everything seems to be pretty good. The worst thing is the outside case, which is a bit, it could use a bit of buffing. And the inside, the front of it, the back, I might take some fine steel wool to it. Since it's nylon, it will buff down to a nice finish. And the front is kind of dirty and dusty. So I'm going to clean them all off, and then the radio will be ready for display and use. Here we have the radio back in its case. I put a bit of lubricant in the volume control to get rid of the scratchiness, and I put a little bit of lubricant in the bearings of the tuning capacitor. Here is the radio all put back together again, and after being cleaned and scrubbed, and there's some physical imperfections like that, and there's some scrapes, but considering it's the best part of 70 years old, it looks pretty good. The main cosmetic damage was we had extensive scrapes in the back here, in the battery door, and up and down here. We had really deep scrapes. And I was able to burnish them out using 4/0 steel wool and soap. And I think I got 90% of the scrapes out. And one thing, it took away the sheen, but there are ways of putting a sheen back if I wanted to. It just looks a lot better. It's quite nice looking now. So anyway, I'm going to show how sensitive this radio is. Here is the radio tuned into a station at 1050. It's 5,000 watts, and it's over about 120 miles away. It's weak and it's noisy, but you can understand it. And there's still quite a bit of volume. It's quite amazing for a 1958 radio. Now here is a radio I bought probably in the last 5 years. It's a Texan 380, very sensitive AM shortwave multiband radio with adjustable filters. So it's pretty new technology. And look how weak the Zenith gets that station better. You can just barely hear it. Even
nothing? Okay, now let's ask for more. And that's what he showed. Of course, you know that
has adjustable sensitivity.
Comes because of the Lord, and
when it locks in on the station, it increases its gain automatically. But still, considering that one radio is about 70 years older than the other, it's amazing. Here again, I'll show the difference.
along the coastal highway, and then it's an turn right at
This radio has on local stations is kind of a harsh sound, and it's kind of stressful to listen to it. Local stations, but it's fine on distant stations. So it might have something to do with the automatic gain control. I have the same problem, the harsh sound, on the other Zenith that I got working, the other Zenith Royal 500. Might be just something inherent in the radio, but I'm sure it's something that can be fixed. I'll just have to do some more research on it. But it's fine for distant stations, which is mainly what I would use it for. There's nothing to listen to on local stations anyway. I have to listen to distant stations at night to get the music I like. Anyway, I think this radio is finished. So that scratchy walkie-talkie quality sound really was starting to get on my nerves. So I went back and I thought about it, what I was going to do. So what I did was I took the signal tracer and I put it right there, right after the diode, and the sound was excellent. So I realized that the problem is somewhere in the driver stage or the output stage. So what I did was I substituted a transistor for the driver, and it didn't change anything. Then I thought maybe I had put in these transistors backwards, because not backwards, but I had substituted this transistor for this one. I had them out to test them. So I switched the two transistors, and it definitely sounded better. So quite often I figured this was probably a problem with crossover distortion. And I tried a number of different transistors, and some were worse and some were better. I had already checked this resistor and these. They were all okay. So it wasn't a bias problem. So I just started substituting transistors in the output. And I took these two Russian transistors, which I have, which have never been used, and I put them in as a substitute for the ones that were in the output circuit, the push-pull ones. These ones, the ones that were here. Here's the driver, and these are the push-pull transistors. And the radio sounded excellent. There was very little distortion and everything. So I realized I was on the right track. So realizing that I could have cut them down, but they're just too big to fit in neatly in this configuration. So I thought I would look through my stash of old transistors, and I got two Japanese transistors, two SB175s, and I put them in, and they sounded just as good. So I'm going to keep these two transistors in there. It just sounds excellent. And the old transistors there, that's the old transistors. And amazingly enough, in the transistor tester, they check fine. They check that they're okay. So maybe the characteristics have changed so much that they're just not efficiently. Maybe they were, when they were put in, they were okay and they sounded fine, but over the years the characteristics have changed, so maybe they're not working very well together anymore. Other than that, they're probably okay, as long as they're not working push-pull. They are, I measured the characteristics, and they are quite a bit different. Like, they should be matched better. So obviously they don't match very well, and that's what is causing distortion. So now I'll let you hear what the radio sounds like. Totally different. Here I've measured the two transistors a number of times. In comparison, transistor number 1 has an HFE of 68 and a VF of 140 volts. HFE is the beta, and VF is your voltage, bias voltage. And transistor 2 has an HFE as 90 and a VF of 157 millivolts. So that difference in gain could have possibly created the distortion I was hearing. So, but both transistors seem to be fine. And this device is very quick to find bad transistors. So all I can say is that they're probably okay. So I'll hang on to them. They can probably be used for other things as I restore other Zenith radios of that era. I thought I would check the transistor with this go no-go tester that I used in earlier, and it shows this transistor's been completely leaky. I'll test the other one just to make sure. Now I'm testing the other transistor, and it's fine. So it just goes to show you that you can't always believe your transistor testers. Germanium transistors are leaky at the best of times, so sometimes it takes a number of ways of determining if transistors are bad. The substitution method and 2 different testers.